Hi everyone, Assalamualaikum. In this video, we are going to continue higher order partial derivatives. Now we look at example 3 from the previous semester papers. If uxy equals to ln x squared plus y squared, evaluate x squared del 2u over del x squared plus 2xy del 2u over del x del y plus y squared del 2u over del y squared. Give your answer in the simplest form. Alright, before that, del 2u over del x squared equals to uxx. Del 2u over del x del y equals to uyx. Notice that when we use del symbol, we differentiate from the right. Means we differentiate with respect to y first. And after that, we differentiate with respect to x. If we use u symbol, so we use uyx. Means we differentiate with respect to y first, and after that we differentiate with respect to x, right? Del 2u over del y squared means uyy, okay? So we can write this expression into the form of x squared uxx plus 2xy uyx plus y squared uyy, okay? Since we have uxx here, so first step, we need to find uxx, okay? Before we find uxx, we need to find ux first, okay? Ux here means we differentiate u with respect to x. We treat x as a variable. And at the same time, we treat y as a constant. To find ux, we need to differentiate from u. Okay, u equals to ln x squared plus y squared. Since we treat x as a variable, so we can use x in different colors to avoid error and easy to differentiate. Okay, so now we can differentiate u with respect to x, and the symbol is ux. Okay, when we differentiate ln, the answer is 1 over the function inside ln, which is x squared plus y squared. And after that, we differentiate the function inside ln. Okay? So, multiply by, we differentiate function inside ln. X we treat as a variable. So, when we differentiate x squared, we get 2x. And then plus y we treat as a constant. So, when we differentiate constant, it equals to 0. Or we can just imagine, okay, if we want to differentiate ln x squared plus 4, 4 here means, let's say we replace y equals to 2. So we get 2 squared equals to 4. So let's say we want to differentiate ln x squared plus 4 with respect to x. So the answer equals to 1 over x squared plus 4, and then multiply by, we differentiate the function inside ln. So we have 2x plus 0. Okay, so that's why we get this. Okay, and after that we can simplify ux. So we get 2x over x squared plus y squared. Alright, so after we find ux, so we can find uxx. Okay, uxx means we differentiate ux with respect to x. We treat x as a variable, and we treat y as a constant. To find uxx means we need to differentiate from ux. Okay, ux equals to 2x over x squared plus y squared. And then uxx here means we differentiate with respect to x. We treat x as a variable. So since we treat x as a variable, so to avoid error, we can use variable x in different colors. So from here, we have variable x in numerator and denominator. Means that to differentiate, we need to use quotient rule. Okay, and when we use quotient rule, we need to identify u, v, and then find u prime and v prime. U equals to numerator which is equals to 2x. Then when we differentiate with respect to x, so we get 2. Okay, v equals to denominator, which is x squared plus y squared. Okay, when we differentiate x squared, okay, x is a variable. So when we differentiate x squared, we get 2x. And then y is a constant. When we differentiate constant, it is equals to 0. No need to write. Okay, plus 0 here. Okay, and after that, when we differentiate ux with respect to x, okay, the symbol is uxx. And then we substitute into product rule formula. Into quotient rule formula. Okay, vu prime minus uv prime over v squared. Okay, so uxx equals to, we multiply v and u prime. So we can cross multiply here. 2 times x squared plus y squared. And then we have minus sign here. And then we multiply u and v prime. So we get 2x times 2x. After that, we expand the numerator. So we get 2x squared plus 2y squared minus 4x squared. Okay. Alright, and then we can simplify numerator here. 2x squared minus 4x squared equals to minus 2x squared. Okay, then we still have 2y squared in front here. So uxx equals to 2y squared minus 2x squared over x squared plus y squared bracket squared. Okay, so this is our uxx, right? Alright, now we done find uxx. Okay, so after that we can find uyx and uyy. To find uyx and uyy means we need to find uy first. Okay, alright, to find uy we differentiate from u. Okay, u equals to ln x squared plus y squared. Okay, uy here means we differentiate u with respect to y. Okay, we treat y as a variable and we treat x as a constant. Okay, since we treat y as a variable, to avoid error and easy to differentiate, we can use variable y in different colors. Okay, alright, so now we can differentiate u with respect to y. So we have 1 over x squared plus y squared times 0 plus 2y. Alright, how we get this? We can just imagine. Let's say we want to differentiate ln 9 plus y squared with respect to y. 9 here means, let's say we replace x equals to 3 because now we treat x as a constant. So let's say x equals to 3, so 3 squared equals to 9. So now, let's say we have ln 9 plus y squared. If we want to differentiate ln 9 plus y squared with respect to y, so we get 1 over 9 plus y squared. And after that, we differentiate the function inside ln. We differentiate 9 equals to 0, and then plus, we differentiate y squared with respect to y, so we get 2y. Okay, so from here, when we differentiate ln x squared plus y squared, so we get 1 over x squared plus y squared, and then time, we differentiate constant, x we treat as a constant, equals to 0. And then plus, we differentiate y squared, y is a variable, equals to 2y. Okay, and after that, we simplify, so we get uy equals to 2y over x squared plus y squared. Alright? Alright, after we find uy, so we can find uyx. Okay? So, to find uyx, before that, uyx means we differentiate uy with respect to x. We treat x as a variable, and at the same time, we treat y as a constant. Okay? To find uyx, we differentiate from uy. Okay? So uy equals to 2y over x squared plus y squared. Since we treat x as a variable, so to avoid error and easy to differentiate, so we can use variable x in different colors. So from here, we only have variable x in denominator. So means that no need to use quotient rule. Okay, we still can use quotient rule, but the method is quite long. Okay, so in this case, we can use generalized power rule because we only have variable x in denominator. When we use generalized power rule, what need we do is we move denominator to numerator here. So we get 2y times bracket x squared plus y squared to the power of -1 using the properties of indices. Okay. Alright, so from here, we can differentiate uy with respect to x, and the symbol is uyx. When we use generalized power rule, we just move the power in front here, and then we still have constant here, and then we copy the function inside bracket x squared plus y squared, and then we reduce 1 from the original power, means -1 minus 1 equals to -2. And after that, we differentiate the function inside bracket. So we have x squared. When we differentiate the function inside bracket here, okay, so x squared we differentiate, we get 2x, and then plus we differentiate y squared, we get 0 here because y we treat as a constant. Okay, and after that, we simplify, so we get -2y times 2x, so we get -4xy, and then x squared plus y squared, and then to the power of -2. Okay, so uyx equals to -4xy, and then we move x squared plus y squared to the power of -2 to denominator. So we get -4xy over x squared plus y squared bracket to the power of 2. Okay, so from here, we done find uyx. Okay. From the previous slide, we done find uxx and uyx. Now we need to find uyy. We still under step 2, find uy, uyx and uyy. Okay, so now we want to find uyy. To find uyy, we differentiate from uy. Okay, from the previous slide, uy equals to 2y over x squared plus y squared. Alright, uyy means we differentiate uy with respect to y. We treat y as a variable, and at the same time we treat x as a constant. So to avoid error and easy to differentiate, we can use different color in variable y. Okay, so from here we have variable y in numerator and denominator. So means that we need to differentiate using quotient rule. Okay, and when we use quotient rule, we use formula vu prime minus uv prime over v squared. Okay, alright, u equals to numerator 2y, and v equals to denominator x squared plus y squared. Then we differentiate with respect to y. So we differentiate 2y with respect to y, we get 2 here. And then we differentiate x squared plus y squared with respect to y. So we get 2y, because when we differentiate x squared, x we treat as a constant. So when we differentiate, it becomes 0. No need to write. Okay, 0 plus 2y. Okay, and after that, we can find uyy. We substitute into this formula. V times u prime. Okay, so we have 2 times x squared plus y squared, and then minus sign. Okay, and then u times v prime. Okay, so 2y times 2y here, and then over v squared. V equals to x squared plus y squared. Okay, And after that, we expand the numerator. So we get 2x squared plus 2y squared minus 4y squared over x squared plus y squared bracket squared. And then from here, we can simplify. So we get uyy equals to 2x squared minus 2y squared over x squared plus y squared bracket squared. Okay, this is our uyy. Okay, so now we done find uyy. Okay, we done find uxx, uyx and uyy. Okay. Alright, from the previous slide, we done find uxx, uyx and uyy. Now we can continue with step 4. Evaluate x squared del 2u over del x squared plus 2x del 2u over del x del y plus y squared del 2u over del y squared. Okay. Alright, del 2u over del x squared equals to uxx. So we recall back, okay? Uxx from the previous slide equals to 2y squared minus 2x squared over x squared plus y squared and then bracket squared, okay? And then uyx equals to del 2u over del x del y. So we recall back from the previous slide, we get uyx equals to negative 4xy over x squared plus y squared bracket squared. Okay. And then uyy equals to del 2u over del y squared. So we recall back from the previous slide, we get uyy equals to 2x squared minus 2y squared over x squared plus y squared bracket squared. Okay, and then we can multiply uxx by x squared here. Okay, so when we multiply, so we have x squared here and then multiply by ux here. Then we can expand. We just multiply x squared with numerator only because x squared here means x squared over 1. So 1 here we multiply by denominator. So we only multiply x squared by numerator. So we get 2x squared y squared minus 2x to the power of 4 over x squared plus y squared bracket squared. Okay, and then we find 2xy times uyx. Okay, alright, so we have 2xy times uyx equals to negative 4xy over x squared plus y squared bracket squared. So after we multiply, so we get negative x squared y squared over x squared plus y squared bracket squared. We just multiply numerator only because 2xy here means 2xy over 1. Okay, and then we find y squared uyy. Okay, so we have uyy here and then we multiply by y squared. Okay, so after we multiply, we get 2x squared y squared and then minus 2y to the power of 4 over x squared plus y squared bracket squared. We just multiply y squared by numerator only because y squared here means y squared over 1. Okay, alright, so after that we substitute into x squared del 2u over del x squared plus 2xy del 2u over del x del y plus y squared del 2u over del y squared. Okay, and at the same time, del 2u over del x squared equals to uxx. Okay, del 2u over del x del y equals to uyx. And del 2u over del y squared equals to uyy. Okay, and then from here we replace x squared uxx, okay, equals to 2x squared y squared minus 2x to the power of 4 over x squared plus y squared bracket squared and then plus 2xy uyx here, okay, from here. Okay, so plus negative 8x squared y squared over x squared plus y squared bracket squared, and then plus y squared uyy, okay, means 2x squared y squared minus 2y to the power of 4 over x squared plus y squared bracket squared. Okay, from here we have same denominator, so we can combine all the denominators. So we get 2x squared y squared minus 2x to the power of 4 plus and minus, so we get minus here. So minus 8x squared y squared, and then plus 2x squared y squared minus 2y to the power of 4 over, okay, we combine all the denominators, so over x squared plus y squared bracket squared, okay, and then we get this, okay. Alright, so from here we can simplify 2x squared y squared, and then minus 8x squared y squared, and then plus 2x squared y squared. So we get this, okay, negative 4x squared y squared, and then we still have negative 2x to the power of 4, and then minus 2y to the power of 4, okay. And after that we can expand denominator here, so we get this, okay. And then from here, okay, we can factorize constant negative 2. So we have negative 2 times x to the power of 4, and then minus times plus, so we get back negative 4 here. So we get, so after we factorize, so we get in bracket plus 2x squared y squared, and then after we factorize negative 2, so inside bracket we have plus y to the power of 4, okay. To check whether we factorize the correct function, okay, so we can expand, okay. When we expand, so we should get back, okay, the above function. So when we expand, so we have negative 2 times x to the power of 4, and then minus 4x squared y squared, and then minus 2y to the power of 4. And then from here, okay, we have same factor, okay, so we can simplify, okay. So after we simplify, we get negative 2. So means when we evaluate x squared del 2u over del x squared plus 2x del 2u over del x del y plus y squared del 2u over del y squared, okay, after we evaluate and after we simplify, so we get negative 2 here. So negative 2 here means in the simplest form, right? Coming up next, partial derivatives of 3 variables. If you like this video, you can subscribe. Thank you for watching. Stay tuned. Bye. Assalamualaikum.